Okay, let me just go over some of your homework questions, and let me know if you have specific problems with questions. But let me just talk about number one. So again, the graph of a quadratic looks like a parabola. Okay, there's only one that I can see that for sure is a quadratic, and which one is it? Yeah. So this one for sure is a quadratic. That's a parabola that opens upward. It has two x-intercepts. Now what about E? Okay, so this is the obvious one. What about E? Do you guys think that E could be a parabola?
Yes.
Okay. There's only a portion of this graph shown, so I guess if this continues on, it could very well look an awful lot like a parabola, right? So which graphs appear to represent quadratic relations? You want to say E too?
Yes.
Yeah, okay, I would agree. Are there any other ones? A? Well, here's the thing. Remember, there's no straight line parts in a parabola. They may look like straight line parts, but there's no straight line parts. So this is a straight line, that's linear. This one has the general shape, but because there's a straight line part and a corner, that's no good. That's more like an absolute value equation. That's not. What about F? Okay, this one looks to be like maybe more than one parabola at a time, but this is actually a trigonometric graph. It's like sine or cos of x. So this one is not a parabola. No, that's different. Not that one. And this one again has a straight line, has straight line sections. So that's not either. Yeah, bucket head.
I have a
Question about E. Yeah, go ahead.
So, like on our sheet, it said that the
Negative A value? Yes.
A value, it goes downwards, and it's not gonna have any x-intercepts.
No.
Is that a rule, or is
No. That's just an example. Yeah. So a negative. Yeah. If you have a negative A value, it turns the parabola downward, and depending on where the vertex is or where the graph is situated, you could actually have one intercept if the vertex was right on the x-axis. You could have no x-intercepts if the parabola is below the x-axis and opens downward. Or you could have two intercepts if the vertex is above the x-axis and it opens downwards. So yeah, you could have intercepts or no intercepts. Question?
F is not a graph of sine or cosine.
Sorry?
Sine or cosine should be a perfectly semicircle.
No, not necessarily. There are parameters, different numbers you can add or subtract and multiply that would shift the graph. Yeah. So it's not just, this one is not just sine y equals sine x or y equals cos x, that's correct. But you can shift the graph, you can stretch it, you can compress it, you can do all sorts of things to that shape of graph. So this would be, it's called a sinusoidal graph is what it's called. So it's a variation of a sine or a cosine graph, this one would be. Yeah. But good point. Because it doesn't go through zero, it's neither one, you're right.
Yeah.
It's not just sine. Okay, let's take a look at number two, guys. Okay, so number two, we actually did number two in the notes, or most of it.
The first one is the exact.
C, yeah, look at it says x squared. You see, that's when you expand this, it's going to be an x squared. So this one is a quadratic.
Okay.
So no, A is no, B is yes, C is yes, D is yes, E is no because of this cubed, and F is no because you have x to the power of 1 times x to the power of 2. So that's no.
But wouldn't that just be 2?
Wouldn't what? Sorry, what?
It cannot be x squared.
No, you would have added x squared.
No, because when you do x times x squared, you actually add the exponents. You don't multiply the exponents.
Oh, I see. Okay.
Yeah. Yeah. Good question. State the y-intercept for each quadratic relation. Okay. What relationship does the y-intercept have in quadratics? We didn't really talk about that one in the notes so much. That would be in here, though. I always encourage you to read this. What does it say at the very bottom line here? It says the constant term c is the y-intercept. So if we go back up here, or down here, the y-intercept for each quadratic, the y-intercept, what's it going to be here? Now we got to be careful. We did this one already in the notes, but when you expand this is going to be 2x squared plus 6x. The constant is 0 there. For this one, and again, let me go back to the notes because I think I actually did this one. So which one was it?
Yeah.
This one?
Yeah.
So when you expand this one, I did that over here on the right. When you expand it, you get a constant of 17. Hey, you guys, pay attention? Pay attention. I'm doing your homework for you, so you want to write this down and pay attention. I'm doing your homework for you. You guys realize that? Do you realize this is your homework? Yeah. You might want to be like get a pen in your hand and write this down. So the y-intercept for this one right here, when you have to expand it out and gather like terms, it's 17. How? Okay, well, when you expand out x plus 4 squared, you get x squared plus 4x plus 4x plus 16. And then when you add the 1 on top of that, that's 16 plus 1.
Okay.
Yeah. All right. This one here, it's -6. That's pretty obvious. It shows up right there. And that's it. I added this to the notes as well. A cannot be 0. Why is this condition there?
Because it removes the whole
It's a straight line otherwise.
2x squared, like it cancels it out.
Yes, it removes the x squared term, which is the defining characteristic of a quadratic. So that's the best way to put it. Yep. If a was 0, that would remove this x squared term, which is required for it to be a quadratic. All right. Okay, does the parabola open up or down? Question number 5. Does the parabola open up or down? You tell me what you think and try and tell me why. Let's see if my computer will wake up here. Okay.
Like if the intercept is
So what is it that we're looking for to determine whether it opens up or down again? Who remembers? Yeah, a value, right on. So the a value is the constant term that is multiplied by the x squared term. So what's the a value in this first one here?
1.
It's 1. Yeah. Now is it a positive or negative 1?
Positive.
Positive. So does this open up or down?
Up.
A is up. Up like a cup. And it has a -4 as a y-intercept, if you're interested. B, what does this open up or down, and how do you know?
Down.
down.
Down, why?
Negative 2a.
Here's the x squared term, and the number that is the coefficient in front is a -2. That is down. Very good. What about C?
Up.
Up. Here's the x squared term, and the number that is in front, you have to take this positive as part of the number, and that is up. You bet. Because rearranged, this would be positive 3x squared minus x plus 9 if you rearrange those terms. And finally, what about D?
Negative.
Yeah, it's a negative coefficient on the x squared term, so this is down. So up, down, up, down. Got it?
Yep.
Easy, right? Okay. I'm going to let you guys work on 6 and 7. Or it's just 6, I guess. There's no 7. So just 6. This one, I want you to, it says each table of values lists points in a quadratic relation. Decide without graphing the direction in which the parabola opens. So you have to kind of like map, as x increases, does y go up and then down? That would be opening down. Or does y go down and then up? That would be opening up. Okay? So take a minute, because I know that not all of you have gotten this far. So take a minute and make sure you do this. I will probably comment on this in a bit. Okay? To give you guys a chance to finish your assignment. Okay, a little comment on number 6. So as x increases from -4 to 1, the values go down, 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 and then look, they come back up with this -3. So 12, 5, 0, -3, -4, and then back upwards. So that is coming down and then back up. So that opens up. B, as the x increases, this is -3 to -13 to -3 to +3 to +5, then back down to 3 and -3. So it starts low and comes up to 5 and then goes back down. So that opens down. Good. Now careful, this is, x is increasing to 0. So as we go from left to right, the values are positive, negative, 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 and then back up some more. So -4.5, -5, -4.5. So that goes down, and then starts to bend back up, so that's an opening upward. This one, -4, 19, 40, 59, 76, 91. What do you think about this one?
It's not a quadratic.
Well, it's not a quadratic. Okay, it doesn't appear to be changed. The y values don't appear to be changing direction. But watch this. If I just focused on, this part of a parabola, it wouldn't look like it's changing direction either. So think a little more carefully about what the numbers are doing. So they're jumping up quite a bit here. Are they slowing down at all? Are they getting closer together at all?
Yes.
Here, are they getting further apart?
That's
Now, what's the?
Well, yeah, they are though.
Okay, it's a quadratic relation. So
Closer.
are they getting closer?
They're getting wider.
So this is a difference of 23, right? Then of 21, then of 19,
No, 16 then.
and then 17, and then so on. 15. So what does that mean? So -4,
it's going down.
if they're slowing down,
That means they are reaching to the top.
okay? So look at, they're farther apart, then they're closer together. So what's happening there? You see what's happening?
Closing up.
So is that going to be opening up or down, do you think?
Down.
Probably down then.
Are you?
Got it?
Yeah.
Awesome. Cool, hey? Math's cool. All right, see ya, bye.
You said, oh.
Are we going